This is the third in a series of videos in which we're looking at solution to CSEC AdMaths 2024 paper. So in this video, we'll look at question 3. Now, question 3 part A says, determine the points of intersection of the circle x squared plus y squared minus 4x plus 6y plus 8 equals 0 and the line y equals x minus 6. So let's begin by writing down the equation. So we have x squared plus y squared minus 4x plus 6y plus 8 equals 0. And of course, we also have the equation of the line, which is y equals x minus 6. So what is required of us for this part of the question? Essentially, we're required to solve these equations simultaneously, right? So in the second equation, we have a straight line, of course, and we have y being already expressed in terms of x. So we can, of course, use a method of substitution to substitute for y in the first, that is the equation of the circle, right? So we're going to substitute. So substituting for y in the equation of the circle. So what does this mean? It means that basically anywhere we see y, we're going to replace it with x minus 6. So let's just write down the equation again. We have x squared plus y squared minus 4x plus 6y plus 8 equals 0. So we're going to be replacing y with x minus 6. And therefore the equation becomes x squared plus x minus 6 squared minus 4x plus 6 times x minus 6 plus 8 equals 0. So having made that substitution, our equation is now reduced to a single variable x, and we can then expand our brackets, simplify, and then solve for x, all right? So let's proceed to doing that. So here we have x squared. Now we are going to have plus, now x minus 6 all squared. Now this is a binomial, and to square this binomial, we're going to have x squared. Then, of course, we're going to have minus 6 times x. So we have minus 6x. Then we're going to have minus 6 times x again. So minus 6x. And then lastly, we're going to have minus 6 squared, which gives us plus 36. All right? So basically, when you square a binomial, you multiply the first term by itself. So x squared. The second term by itself, 36. And then, of course, you multiply these two together twice. Right? And so let's continue. So we get x squared minus 6x minus 6x plus 36 for that expansion of the binomial. We continue, we have minus 4x, and now we have plus 6 times x, that gives us 6x, and 6 times negative 6, that gives us negative 36. And of course, we have our plus 8 is equal to 0. All right? So let's see what we can cancel. So we see that we have plus 36 and minus 36. So those two will actually cancel. We also see that we have, well, I guess you could say that one of this minus 6x will cancel this 6x over there. And I think that's as far as that goes. So if we continue, then what we're going to get is this. We say now x squared plus x squared gives us 2x squared. Then you have minus 6x minus 4x gives us minus 10x. And then, of course, you have, what's that? Plus 8 equals 0. Is that what you're supposed to have? Let me check this one again. So, so x squared plus y squared minus 4x. X squared plus y squared minus 4x plus 6y plus 8 equals 0. So we see x squared plus y squared, x squared plus x minus 6 all squared minus 4x plus 6y plus 8 equals 0. So x squared plus x squared minus 12x plus 36 minus 4x plus 6x minus 36 plus 8 equals 0. Right, so we're on the right track. And so therefore we have 2x squared minus 10x. So let me deal with these. So we have x squared plus x squared gives us 2x squared. Then we have minus 6x minus 4x, that gives us minus 10x, right? And so Now we have plus 8 equals 0. Right, so we have plus 8 equals 0. All right, so good to go. So we did our checks and it's good to go. So now that we reduce this to a quadratic equation, what we can do now is to actually make the equation a little bit simpler by dividing both sides by 2. So dividing through by 2, we get x squared minus 5x plus 4 is equal to 0, right? And at this level, we should be able to factorize this. So we see that a is equal to 1, b is equal to minus 5, and c is equal to 4, right? So in this case, we have a equals 1, b is equal to negative 5, and c is equal to 4. And so typically we say, well, AC as 1 times 4, which gives us 4. And then we ask ourselves what factors of positive 4 add to give negative 5. And those factors are minus 1 and minus 4. And so therefore, when we factorize this, what we're going to get is this. X minus 1 times x minus 4 is equal to 0, which means x minus 1 equals 0, x is equal to 1, or x minus 4 equals 0, which means x is equal to 4. So these are the x coordinates of our 2 points of intersection. Now we need to find the corresponding y coordinates. But since we already have y in terms of x from the straight line equation, then we can actually just substitute them into this equation. Y is equal to x minus 6. So let's write down our equation. So we have y equals x minus 6. And so when x equals 1, we have y equals 1 minus 6, which gives us negative 5. And when x is equal to 4, we have y is equal to 4 minus 6, which gives us negative 2. And what this therefore means is that our points of intersection are 1 minus 5 and 4 minus 2. So these are the points of intersection of this circle, x squared plus y squared minus 4x plus 6y plus 8 equals 0, and the straight line y equals x minus 6. All right? So that is that part of the question there. Now, let's move on to part B of the question. Now, part B says, given that the coordinates of the points A and B are 7, minus 3, and 2, 1 respectively, state the position vectors corresponding to the points A and B in the form xi plus yg. So this part of the question deals with vectors, and we're given the coordinates of 2 points A and B, and we're told to state the position vectors which correspond to these points in the form xi plus yg. All right, so let's proceed to doing that. So these are our points. We have A, which is a point, 7, minus 3, and we have B, which is a point, 2, 1, right? So therefore, what this means is that the position vector OA would be given as 7i minus 3j. So these, of course, are in the form xy. This is also xy. And of course, in the form xi plus yg, then OA equals 7i minus 3j, and OB would be equal to 2i plus g, right? So that is that right there. The next part of the question says determine AB. Now in this particular case, what we're required to find is the displacement vector AB. And of course, whenever we have a displacement vector such as this, AB, then this of course is equal to OB minus OA. And so it is a position vector associated with the second letter B minus a position vector associated with the first letter A. And so we get OB minus OA. And when subtracting these position vectors, we essentially subtract the I coefficients together and the J coefficient. So therefore, this gives us, so we have OB, which is 2I plus J, and we're going to be subtracting OA, which is 7I minus 3G. So what this gives us, we have 2I plus G, then we expand this out, we get minus 7I, then you have minus times minus 3G, which gives us plus 3G. And now we can combine the I coefficients. So this will be 2 minus 7, which gives us minus 5I, Then you have j plus 3j, which gives us 4j. And therefore, the displacement vector AB is given as minus 5i plus 4j. All right? So that is that part there. Now, let's go on and move on to part 3 of the question. Now, part 3 of the question wants us to find the scalar product or the dot product OA dot OB. So once again, let's write down OA and OB. So we have OA is equal to 7i minus 3g. And we have OB, which is equal to 2i plus g. Now, whenever we are finding the dot product of two vectors, we multiply the coefficients of I together and the coefficients of j together, and then we add those, right? So say that OA dot OB would be equal to 7 times 2 plus minus 3 times 1, which gives us 14 minus 3, which of course is equal to 11. And therefore the dot product of these two vectors is equal to 11. All right, so that's the end of part B of the question, and we'll then move on to part C. Now, part C. Part C shows us a right angle triangle with sides P, Q, and R. We can see that the side P is opposite the angle theta. Excuse me. R is adjacent to the angle theta, and of course it means that side Q would be our hypotenuse, right? Now, they want us to obtain expression with each of the following trigonometric ratios: sine theta and cos theta. Now, if you remember your little what do you call it again? These are things we call mnemonics. Is that name? No, that's not the word. Remember the word? Is that mnemonic? Something to that effect. But anyways, this is it. Remember SOHCAHTOA, right? SOHCAHTOA, right? So SOHCAHTOA. So what this basically means is that the sine of the angle, so we say sine theta is equal to opposite over hypotenuse. Similarly, cos theta would be equal to adjacent divided by the hypotenuse. And of course, tan theta would be equal to opposite over adjacent. Now, in this particular question, we're not required to calculate tan, but just for completeness, we state the trig ratio in terms of the other side of the triangle. So, based on our triangle, as I said before, the opposite is P, and of course, our adjacent is R, and our hypotenuse is Q. So this, of course, is our adjacent, that is our opposite, and this, of course, is our hypotenuse. And so we can therefore say that sine theta is equal to P over Q. Similarly, cos theta is equal to adjacent, which is R, over hypotenuse, which of course is Q, right? So those should have been easy marks for that part of the question. Now, part 2 says, using your answers in C part 1, determine the value of sine squared theta plus cos squared theta, right? And of course, you're supposed to recall that sine squared theta is equivalent to sine of theta squared. So, if we go to sine squared theta plus cos squared theta, what this gives us is this. So sine squared theta would of course be equal to P over Q squared, which of course is equal to P squared over Q squared. Similarly, cos squared theta would be equal to R over Q squared, which of course is equal to R squared over Q squared, right? Now, what this therefore means is that we can say that sine squared theta plus cos squared theta would be equal to P squared over Q squared plus R squared over Q squared. Since you have the same denominator, we can just add the numerators and keep our denominator. So this gives us P squared plus R squared over Q squared, all right? However, we're talking about a right angle triangle. And in a right angle triangle, according to Pythagoras' theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. What exactly does this mean? In particular, in this triangle, we'll see that Q squared is equal to P squared plus R squared. So according to Pythagoras' theorem, P squared plus R squared is equal to Q squared. And so therefore down here now we can say that sine squared theta plus cos squared theta will be equivalent to Q squared over Q squared, which of course is equal to 1. And this of course is an identity that would have been familiar with. And so this is what we would have expected, that sine squared theta plus cos squared theta would be equivalent to 1. Okay? Now, the next part of the question requires us to prove the identity, right? So they want us to prove the identity that tan A plus 1 over tan A is equivalent to or equal to 1 over sine A cos A. Now, let's examine both sides of this trig identity and try to determine which of the two sides appear to be the more complicated of the two. So we're required to prove, required RTP, not RQ. So we're required to prove, so RTP, that tan A plus 1 over tan A is equivalent to 1 over sine A cos A. So it would appear that the left-hand side is the more complicated of the two sides, and so it is better to start with the left-hand side than the right-hand side. However, of course, you must remember that, for instance, tan A would be equivalent to sine A over cos A. And therefore, this would imply that 1 over tan A would be equal to the reciprocal of that, which of course is cos A sine A. All right, now let's proceed. So the left-hand side, the LHS, is equal to sine A over cos A plus cos A over sine A. Draw a line below and write down a common denominator, which of course is cos A sine A. And then we say cos A into cos A sine A. The cos A's of course will cancel. And this leaves us with sine A. And we say sine A times sine A. That gives us sine squared A. Right? Now, similarly, over next side now, we basically would say that sine A into sine A cos A, the sine A's will cancel, leaving cos A, and therefore cos A times cos A gives us cos squared A. So we end up with sine squared A plus cos squared A all over cos A sine A. And of course, we should know that from our trig identities, this of course is equivalent to 1 over cos A sine A. And is that the right hand side? Yes, because of course multiplication is commutative, so therefore cos A sine A is the same thing as sine A cos A, and this means that we've proven our identity. And so we can say that tan A plus 1 over tan A is equivalent to 1 over sine A cos A. So this is the end of part D and the end of question 3 from CSEC AdMaths of June 2024.